Let us now discuss some problems related with the motion with constant velocity. This is the first one. Two cars A and B are 200 meters apart. They are moving toward each other at the speed 4 meters per second and 6 meters per second respectively. Find the time and the distance traveled by both cars until they meet. Here is the picture of the initial situation. Both cars are 200 meters apart and they are moving toward each other. The speed of A is 4 meters per second and the speed of B is 6 meters per second. So this is the initial situation, or t is equal to 0. And now after 1 second, car A has moved 4 meters and car B has moved here 6 meters. So the distance between them after 1 second is 190 meters. Here again I show you the situation at t is equal to 0 where the distance is 200 meters and the situation at t is equal to 1 where the distance is 190 meters. And when the time is equal to 2 seconds, you will see that the distance traveled by A is 8 meters and the distance traveled by B is 12 meters. So now their distance is 180 meters. In other words, every second they become closer 10 meters. How this 10 meters come from? Well, it's just 4 plus 6. Yes, the addition of their speeds. So you can imagine, if every second they become closer 10 meters every second, they become and their initial distance is 200 meters. So you can calculate that both cars will meet after this distance 200 meters divided by 10, or they will meet in 20 seconds. And the distance traveled by A after 20 seconds, since A is moving with 4 meters per second, so after 20 seconds it will move 80 meters, and B here is 6 meters per second, so after 20 seconds it will move 120 meters. Let us now take a look on the second problem. Actually, this is similar to the first one, but now car A moves 5 seconds earlier than car B, and here we are asked to find the time and the distance traveled by both cars until they meet. This is the initial situation of this problem. The first important thing we need to think about here is the distance traveled by A in the first 5 seconds. I will call this 5 seconds as TA. So B actually is still staying at his initial position, and the distance traveled by A is 4 times 5. So the distance after 5 seconds here is 20 meters, and B is still in here. So now after 5 seconds, the distance between A and B is 180 meters. So this is the situation after A moves 5 seconds, or we can say the time for B is 0. And this is the distance traveled by A, 20 meter, and the distance between A and B now is 180 meter. Now we can start from the time when B starts moving. So the initial distance is 180 meter, and now we have similar situation compared to our previous problem, but the initial distance now is 180 meters. Let's now have a look after 1 second. So after 1 second, when B starts moving, the distance traveled by A here is still 4 meter, and the distance traveled by B is 6 meters. So now after 1 second, the distance between them is 170 meters. Here again the situation when B starts to move. So the distance between A and B is 180 meters, and after 1 second A has traveled 4 meters and B has traveled 6 meters, so the distance between them now is 170 meters. And after 2 seconds, A here has moved 8 meters and B has moved 12 meters. So now the distance between them is 160 meters. As you can see here that their distance become closer 10 meters every second. Therefore, you can predict starting from the time when B move, so the initial distance here is 180 meters. And you already know that every second they become closer 10 meters. So the time needed until they meet is 180 meter divided by 10 meter per second. So you will get 18 seconds. And the distance traveled by A after 18 seconds is 4 times 18. So you will get 72 meters. And the distance traveled by B is 6 times 18. So it will be 108 meters. And here you see the total distance is 180 meters. Therefore, we can always find that if we have two cars, A and B, and they have their speed VA and VB here, and their initial distance is D, and then they are moving towards each other. So the time needed for them to meet is their initial distance D divided by their speed VA plus VB. Alright, now you see a formula here, but I do not recommend you to memorize this one because you can always find like this when you get more practice and practice. Now we move to the third problem. Here we have two cars, P and Q, and they are 10 meters apart. They are moving in the same direction with constant speed 5 meters per second and 3 meters per second respectively. Car Q is in front of car P. So now find the distance and the time when P passed Q. As you already saw the initial situation here that the distance between P and Q is 10 meter and P is moving with constant speed 5 meter per second and Q is moving with constant speed 3 meter per second. Now let's think about the situation after 1 second. So car P moves with speed 5 meter per second, and after 1 second the distance traveled by P is 5 meter, and the distance traveled by Q is 3 meter. So here from here is 3 meter, and the distance from this to here is 13 meter. And you'll see that the distance between P and Q now is 13 minus 5, so you will get 8 meters. And at t is equal to 2 seconds, the distance traveled by P now is 10 meter, and Q now is moving also another 3 meter, so the distance from here to here is 16 meter. So as you see here, the distance between P and Q now is 16 meter minus 10 meters, so you'll get 6 meters. And here you see that every second their distance becomes closer to meters. So how this number actually comes from? Well, you can actually think that this 2 comes from 5 minus 3. Or in other words, we can say that P is catching Q for 2 meters every second. So if their initial distance is 10 meters and every second they become closer to meter, well, you can say that they will meet after their initial distance here divided by 2, or they will meet after 5 seconds. And after 5 seconds, P here has moved, so its speed is 5 meters per second. So after 5 seconds, the distance traveled by P here is 25 meters. And Q here has speed 3 meters per second. So after 5 seconds, the distance traveled by Q will be 15 meters. So they will meet at this point. And also, if we have two cars here, P and Q, and they are moving in the same direction, and the speed of P is larger than the speed of Q, and at the end P will catch Q at the same position here. So the time needed for P to catch Q here is their initial distance here, let's say it's D, divided by Vp minus Vq. This is not the formula that you need to memorize, and I also do not recommend you to do that, because when you practice the problems like this, you will always find that finally you will get the time for this situation will be like this. This is one of my favorite problems in motion. So we have two cars, A and B, and they are 1000 meters apart. They are moving toward each other at the speed 2 meters per second and 3 meters per second respectively. And a bee is moving back and forth between these cars at a certain constant speed 4 meters per second. Find the total distance the bee will cover before the car crash. Perhaps you would think that we can find the distance for each traveling distance of the bee when it flies to one car and then return to another car and then return to the first car, like this, one by one. Well, you can do this, but that will certainly need a lot of effort. Now, read the problems again carefully. We are asked to find the total distance traveled by the bee until the cars meet. Until the cars meet. Yes, that's the keyword. So first, let us find the time needed for the cars to meet. Just like our previous problem, the cars here are 1000 meters apart, and this car has speed 2 meters per second, and this one has speed 3 meters per second. So they will become closer 5 meters every second. And you can calculate now the time needed for these cars to meet. So it will be 1000 divided by 5. So you will get 200 seconds. And this is also the time for the bee to move back and forth. And if the bee has a speed 4 meters per second, then the total distance traveled by the bee here is, well, you can calculate, it is 4 meters times 200 seconds. So you will get 800 meters. So this is the total distance traveled by the bee back and forth until the cars meet here.